Hi, I'm Paul Kyogan from GKTuition, and in this video I want to talk to you about trigonometry. Now the question that I've chosen to go through here is 2017 paper 2 question 9. Now there's a lot of, the diagrams here are very intimidating, and I'm going to talk you through it as we go through the question. But for the first part of the question, it starts by saying use the triangle ECT. So the rest of the diagrams are irrelevant. You literally just need this triangle. It says use the triangle ECT to get the distance TE in the form root A times CT. So the only thing I'm concerned with is this triangle. Now they've told me that the TE, the line TE, is a vertical tree. So because it's a vertical tree, I know that that's 90 degrees. And I know that this one is 60 degrees. Now if you have a right angle triangle and you're given an angle, the first thing that should come into your mind is sine, cos and tan. In this case, I know that in my answer I need the distance TE. I want to get TE in the form root A CT. So I know it's something to do with this side and it's something to do with that side. So if you've identified it's a right angle triangle, you're dealing with an angle, it's something to do with that side and that side, that's more or less, you should recognize what the question is now. If that's 60 degrees, then this is your opposite. If that's 60 degrees, then this is your adjacent. So you should realize that in your answer, you need the opposite and you need the adjacent. If you're dealing with opposite and adjacent, you must be dealing with tan. So I could say that the tan of 60 is equal to the opposite over the adjacent. In this case, the tan of 60 is the opposite, which is TE, over the adjacent, which is CT. And I know that this is the route I want to go down because now at least I've got an equation with TE and CT in it. The question said to get TE in terms of root A CT. Clearly I need to get TE on its own. So to get rid of my fraction here, I would multiply both sides by CT, which means that TE is actually tan 60 times CT. And if you plug tan 60 into your calculator, or if you look it up in your log tables, it's just the square root of 3. So you just get root 3 CT is equal to TE. And that is your final answer for the first part of this question. In part B of this question, we need to now start talking about our diagram. T represents the base of a tree and E represents the top of the tree. The distance from T to C is a horizontal line along the ground. And the distance from C to E is from one side of the river to the top of the tree on the other side of the river. So the triangle ECT that we used earlier was a right angle triangle going from the top of a tree over to the far side of the bank and back to the base of the tree. You should see that the distance E dt is similar. D is also a point on the far bank, T is the base, E is the top of the tree. But what you really need to hone in on are the 3 points that are on the ground, the points D, C and T. If you look at figure 1, it's quite clear that DCT is a right angle triangle. And I know that the distance DC is 15 and the distance CT is, well, it's CT for the moment. Now, when you've got this diagram, you should look at your answer. The answer that I'm trying to get to is that dt is equal to the square root of 225 plus ct squared over 3. So obviously at some point I'm going to have to square ct. At that point you might notice that 15 squared is actually 225. So at some point I'm also going to have to square that side. If you're going to be squaring that side and you're going to be squaring that side and it's a right angle triangle, then clearly you're going to be using Pythagoras theorem. So in order to get to that answer, chances are I'm going to be using my Pythagoras theorem. Obviously the problem I have then is the distance dt, the side dt. I don't want a dt in my answer, instead I want a te in my answer. In the first part of the question, we use the triangle ECT in order to get the length of the tree in terms of this line, the distance CT. And that I could do that because I knew one of the angles at the base was 60 degrees. If you look at the triangle EDT, you have the same amount of information about this triangle as you had the triangle that we used in the first part of the question. So logically I should be able to get this distance, the length of the tree, in terms of this base. I know that the length of the tree, that's your opposite and that's your adjacent. So I could say that the tan of 30 is equal to the opposite divided by the adjacent. Now if I wanted to get rid of my fractions there, I could multiply both sides by dt. And I would get dt tan 30 is equal to te. Now you should recognize what we're trying to do is we want to isolate dt. We want to be able to sub in something instead of that length, because we don't want to, if we're using Pythagoras, we don't want to use dt because it's not in the answer. So I want to isolate this distance, the distance dt. In order to do that, you need to divide both sides by tan 30. If you divide both sides by tan 30, in this case, you would end up with dt is equal to the square root of 3 times te. Okay, so you would work out dt is equal to root 3 te. And this is useful to me now because I can sub it into this right angle triangle. Instead of dt, I could put in root 3 times te. Now all of a sudden, if you look at what this diagram here, and if you look at the answer, we should be able to get to it. I need to square, if I square ct, I'll get ct squared. If I square 15, I'll get 225. If I square 3, I'll get a 3. So hopefully, by looking at that, you should hope that you'll get to your diagram. So that was tricky to make that link, but now we can just use Pythagoras' theorem, and it's a very straightforward question. So, as you can see, I've drawn out my triangle now. I know the hypotenuse is root 3 te, and the sides are 15 and ct. So if I use Pythagoras' theorem, remember you're subbing into the formula a squared plus b squared is equal to c squared, where in this case c is the hypotenuse root 3 over root 3 multiplied by te. If I sub in, I get 15 squared plus ct squared equals root 3 te squared. So that's 225 plus ct squared. Root 3, if I multiply it by itself, I get 3. Te, if I multiply it by itself, I get te squared. In order to get te squared on its own, I divide both sides by 3 and I introduce this fraction. Now I clearly don't want te squared, I want just te, so I get the square root of both sides and you end up with root of the fraction you had above. And that's your final answer for this part. Okay, so for part C of this question, it then says, hence find the value of ct, or find the distance from Connor to the base of the tree. In order to find ct, you need to look at the previous two parts we've done. In part A, we worked out that te is equal to root 3 ct. In part B, we worked out that te is equal to that. If the first answer is equal to te and the second answer is equal to te, then clearly the two of them are equal to each other. So when you let them equal to each other, you should notice that you've one equation and you've got one unknown. Now you have a lot of complications here, but you need to isolate your ct. The first thing I did here was I squared both sides. If you square the left, you get 3 times ct squared. If you square the right, then the square root is just cancelled. The square root is gone. Now, in order to get rid of this fraction, I multiply both sides by 3, so the fraction is gone, just disappears on the right-hand side, but you multiply 3 by 3 gives you 9 ct squared equals 225 plus ct squared. Now, you need to recognize that the term on the left here and this term on the right are like terms, which means that you just bring, if you have plus ct squared on the right, if you bring it across, it becomes minus ct squared. Or in other words, I just subtract ct from both sides. So you get 9 ct squared minus 1 ct squared equals 225, which works out as 8 ct squared equals 225. So if you simplify it down, you'll get ct squared is equal to 225 divided by 8. In order to get ct on its own, you get the square root of both sides. So ct is obviously just root 225 over 8. Plug it into your calculator, it's 5.3033 meters. It asks you to leave it to one decimal place, so your final answer is ct is equal to 5.3 meters. Once you've got part C right, part D is very straightforward. It says now find the distance te. First part of the question we said te is equal to root 3 times ct, and in part C of this question we worked out a value for ct as 5.3. So you just multiply root 3 by 5.3 and te works out as that. But it asked me to get it to one decimal place, so it's 9.2 meters. In part E of this question, we're told that the tree falls and lands at the point F on Connor's side of the river. So it's going to fall on the riverbank where Connor is standing. And you need to take into account that the tree is much taller than the distance between Connor and the tree. In other words, we've worked out the distance from Connor to the tree is 5.3 meters, but the actual height of the tree is 9.2 meters. So imagine the tree just landed straight directly on top of Connor. The middle part of the tree would hit Connor and the tip of the tree would be somewhere out here. It would be an extra, because the distance from T to the tip of the tree would be 9.2 meters. So I need to figure out how big can the angle get, so at what angle does it need to land so that the very, very tip of the tree is at the edge of the riverbank. Obviously, as you increase the angle FTC, the tip of the tree gets closer and closer to the riverbank, up until the point where the distance between T and the point F would be the same as the height of the tree. So in fact, let's ignore the F that I've put in here. This is the scenario they're talking about. If I kept on increasing that angle up to a point where the distance from T to the point F is actually the same as the distance TE, or in other words, the height of the tree. The height of the tree is 9.2 meters. If the distance from T to F was 9.2 meters, that is the maximum possible angle for which the tree will still land on this side of the river. Now, if I increase that angle, the tree would land in the river and it would float away, or basically it wouldn't be landing on the bank. Now, this question was actually really tricky. Like, you could take it as, first of all, right, you've worked out CT as 5.3 and you've worked out TF as 9.2. So you work off the assumption that, happy days, if I need to find this angle, I know the adjacent and I know the hypotenuse. Unfortunately, if you use the figure 5.3 and the figure 9.2, you'll lose marks because we've rounded both of those off to 1 decimal place. In order to get the full marks here, you have to actually go back to the very start of the question. The very start of the question, we said that TE is equal to root 3 CT before we did any rounding off whatsoever. And I'm going to use that in order to find the angle theta here. Ignore that for a moment and let's just think about it. You have a right angle triangle and you know 2 sides. If you have a right angle triangle and you know 2 sides and you're looking for the angle, then clearly it's either sine, cos, or tan. In this case, the 5.3 is the adjacent, the 9.2 is the hypotenuse, which means clearly you're looking at the cos of theta is equal to the adjacent, which is CT, over the hypotenuse, which is TE. The distance TE and the distance TF are the same thing. Now here, I think most of you, your instinct would be to fill in 5.3 and to fill in 9.2. But unfortunately, as I mentioned, if you actually use those figures, you won't get the right answer because those are rounded to the nearest decimal place. In order to get the right answer here, we need to accommodate for this. The cos of theta in this case is the adjacent over the hypotenuse. The adjacent being CT, and the hypotenuse, instead of TE, I can sub in the square root of 3 times CT. So in fact, I can actually write the hypotenuse in terms of CT. So now I can say that the cos of theta is CT over root 3 CT. If I just divide the top and the bottom by CT, or essentially they cancel out, you end up with 1 over the square root of 3. So in fact, the most accurate way of describing cos theta is 1 over the square root of 3. Cos theta is 1 over the square root of 3. To get theta on its own, it's simply cos inverse 1 over the square root of 3. And if you plug that into your calculator, you get 54.7 degrees. So the final answer in that case was 54.7 degrees. If you use the figures 5.3 and 9.2, in other words, if you had said cos theta is 5.3 over 9.2, your answer would have been 54.8 degrees. So that was a really harsh, that was a tricky one, where just maybe take that into account when you're going into your leaving cert. Always try and use the figures that are as accurate as possible. Clearly this one was 100% accurate because I hadn't done any rounding off at all. That was the answer I got to the first part of the question. In the final part of this question, we're told that the tree is equally likely to fall in any direction. And we're asked to find the probability that it falls on Connor's side of the bank when it falls. Okay? First of all, you need to realize that obviously we've worked out that there's the angle with which it could fall below Connor here is 54.7. Obviously, if it could fall on the other side, it could fall above where Connor is, and that would obviously be the same. It's 54.7. That would have, because these two triangles would have to be congruent. The distance from here to here and the distance from here to here would have to be the same. So the angle with which it could fall and still land on Connor's side of the bank is 54.7 multiplied by 2. 54.7 multiplied by 2 is 109.4 degrees. Now, if you think the tree is equally likely to fall in any direction, obviously if it's equally likely to fall in any direction, it could fall anywhere within a complete circle. A circle is 360 degrees. So I need to work out the probability or even the percentage chance it falls in this direction. In order to do that, it's Right, well, the favourable outcome is 109.4 degrees over the total possible outcomes is 360 degrees. If I wanted to write that as a percentage, I multiply it by 100 over 1. My final answer to 1 decimal place is 30.4%. There's a 30.4% chance that the tree will land somewhere along here. Okay, so I hope this video made sense. If there's anything there that you're unsure of, or you want me to clarify something, then just send me an email or let me know in class and I'll try and clarify it for you.